Start. So thank you again. Welcome to 247. I know there was already one round of welcome in the beginning, but I know a few people who came a little bit later. So thank you again for showing up. I know it's Saturday morning, and we had a really good session which Shashank conducted. In fact, some of the things that I wanted to talk about I actually changed because he actually went into quite a bit of detail. And I think it would be really good if you look at that. I don't know whether this video is shared later in the group. Yeah, so definitely go through it. I think there is a lot of stuff that is condensed in it, and it would be really good if you a lot of things to check out in the talk. So what I will do instead is I will focus a little bit on productionizing Spark applications, like how in our use cases, like we'll go a little bit about discuss about the use cases that we have here, and then discuss how we have productionized a Spark based platform for our model building and model training purposes. So before starting on that, just a little bit of introduction about myself. My name is Samik. I'm a director in the data sciences group. The data science group here consists of around 40, 45 people. That includes people who do R&D on machine learning models. They also include people who take models and customize them for specific client use cases. And then there is another team which is actually works in the interface of engineering and data science. So I actually manage that group. So we work in the interface of engineering and data science. We work with the platform engineering team to make sure that the type of models that we develop are able to scale up to millions of predictions in real time. So that is essentially what our use case is. We'll go through that. But there are there's quite a substantial amount of difference when you have prediction models that needs to run in batch, generate predictions, and then you show them in real time. So this is what happens when you go into Amazon, let's say, and you see that these were the recommended products for you. Those predictions do not happen in real time. They happen in batch and they are shown to you in real time. That versus when you actually have to predict in real time based on user behavior, user journey, and so on. So there is a substantial amount of difference about how you handle those type of cases. So we fall into the later category, and there are actually very few applications where you actually need real-time prediction because of the changing nature of user interactions and things like that. So we'll discuss some of those use cases, and we'll see how our platform for model building and model training actually supports the ability to do that type of real-time predictions at scale for the volume that we support. So yeah, as I mentioned, so we'll go over a little bit about the use cases. We'll discuss about the model management platform, and then we'll discuss a little bit about how much ever we can about how we are using Spark for this whole framework. So a little bit about our company. I know you may have be familiar with the name, but I'm not sure how much you are familiar with like what we do. So we have this is actually a slightly older one. Now we have office in a bunch of other countries. Other than Bay Area and Bangalore, we also have office in Toronto, and we also have office in Stockholm. These are what we call innovation lab offices. So we do core research work in these offices. There are also other centers of our company where we provide the BPO solutions to our customers. That is around 7 or 8 countries around the world. So we use predictive models to drive enhanced customer experience. So this is a very interesting and sort of emerging area where of analytics and big data, mostly because we need real-time predictions, as I was mentioning. We'll go into a little bit more detail on that. But so our machine learning models need to be able to scale in order to do that. And what we typically, what these use cases typically are, they basically would like, they would have to basically predict the intent of the customers in most cases. So if we get to know what is the intent of the customers who are contacting our customer support agents in our data centers, that enables us to provide a superior service, right? Because so for a simple example, right, when you call a data center for, let's say, your bank, your telecom provider, or something, the typical question always is, how can I help you today, right? If there is a question at all, if it is audible and things like that, right? However, there are ways by which, and we have done this for quite a few years now. There are ways by which you in a typical situation, like for almost 85 to 90% of such situation, given the customer's interaction with the channel, in a specific channel with the brand, you can predict with very high accuracy about what the customer has contacted you for. You don't need to ask customer at all. And in fact, you can take a few proactive actions based on your understanding of why the customer is contacting you. And that can help in tremendously improving the customer experience. And it also helps in reducing the time it takes to handle a particular customer. So there are multiple ways by which it kind of affects this whole ecosystem. So we try to do that, and machine learning plays a key role in this whole sort of scenarios. So a little bit about the company, and we had a big data company. We have a large number of customers, Fortune 500 customers, and we handle their customer support operation and customer support and sales operation, and that results in pretty substantial amount of data that gets stored into our data center and how we handle and manage those data, right? For example, we get almost 4.5 terabytes of interaction data per week. And now that, I'll go to the sources, but that this actually encompasses a multiple, in fact, this is a slightly older. We have actually suppressed these numbers quite substantially in the last around 7-8 months. But yeah, so the amount of data that we deal with is quite substantial. So with this data, so the services that we provide are like basically chat agents and voice agents at a very basic level. But there are other products that we provide on top of it, which essentially helps the agents to take those interactions, and also helps the customers to get into, for example, different innovative ways to serve the needs of the end consumers. For example, we have like a application like a vivid speech, where what happens is that when you you are on a call, but let's say sometimes what happens is that the agent asks you, can you fill out this form? So rather than going out in a different channel, let's say you have to open a laptop, you have to fill a form. If you are on a smartphone, it can show you a form right there on the call, get the data, and kind of move on. So there are a lot of innovations that we have done in this regard, in social vivid speech, and that we call that vivid speech. There are other innovations there. And so all these sort of products fall under two basic categories, two basic type of contracts. These are basically either sales sort of contracts or service sort of contracts. So we are responsible for doing sort of customer support for our customers, or we are responsible for augmenting their sales for our customers. So how we look at the data science aspect of all these things, like by doing all these things. So we follow a three-word principle: anticipate, simplify, learn. So what we do is so essentially, like each pillar, you can think of like each pillar like an engine, which does specific which performs specific tasks to achieve the end result of supporting our customers, right? So the first one is anticipate. So we have intent models to determine what is the intent of the customer who is contacting the data centers. So these models span. So there are different type of intents that appear for different vertical, different channel, and so naturally there are models that can encompass those type of intents. The next is the engagement engine. So this is what I was talking about, right? So innovations like, for example, opening a form so that you can capture data on call and things like that. So the engagement engine, and finally, so that leads to, so a superior engagement obviously leads to the outcome that we want to drive for our customers. And not only that, so this is driven by machine learning, so that the data that we receive in that way is again fed back to the intent engine, so that we can continue this cycle of iterative learning from that perspective. Right. So these are some of the sources of data that we have in 24/7. So we have the usual web and web logs. I'll come to the IVR a little bit later. So as I was mentioning, we have two types of contracts, like sales and service contracts. We also support in a majority of scenarios, we support in two specific channels. One is the web channel. So basically, our solution gets embedded into the websites of our customers. We also have a speech platform that we purchased a couple of years back from Microsoft. So that actually handles service calls. So we embed our solution within the speech platform, within the telephony platform, for predictive. We'll come to the use case a little bit later. But so that IVR. So we basically manage the IVR systems for large corporations. So that IVR logs also is one of the major sources of data for us. Obviously, if it is a web, then we calculate the web journeys. Then we get all the transcripts that our customer support agents generate in terms of the day-to-day business, right? We also have presence in embedding in social media for our brands that we serve. So the social media data, customer history, product mix. So we obviously get access to, in some cases, some of the CRM data for that's there with the customers. And that can help us, that basically can be used, in certain cases that can be used in the machine learning models. There are other data that we get from the agent side of like the customer support side of the business, for example, the agent performance dispositions and things like that. So I have a separate slide on the technology. So let us look at a few use cases. These are all intent prediction use cases. So those are the majority of our machine learning model are involved in predicting intents. So this one, for example, this is the intent prediction model for the web visits. So for our clients, I have taken an example of retail vertical, but we do this in multiple other verticals as well. Essentially the same thing. But let's say, for example, in the retail vertical, we provide chat agents who are experienced in providing differential support. So what it means is that, so the support is essentially based on what the intent that we detect from our for the particular customer. So the differentiation can be based on either like the current phase of the journey. So essentially, when you, let's say, think of your last shopping experience on Amazon or Flipkart, right? So you you land at a specific page, maybe starting from Google. You look for a product, you land up in a specific page, then you go through a sort of a small, let's say, research session. You look at multiple products, right? And then you select a product, and then you put it into a cart, and then you check out. Or maybe you keep it for the next session, you come back. And then maybe you have done some offline research, maybe you have visited some stores offline to check out whether the price is better or the quality is better there. And then you have decided, okay, fine, I'm just going to go with Amazon or Flipkart. And then you go there, you probably finish up the transaction. So there's this journey, right? This journey of the customers. And this happens in pretty much every vertical. The journey may not look like this, but there is a journey concept that is applicable to any vertical. And at which phase of the journey you are in, if you can predict that along with the intent, that can help the customer support agent to actually qualify the support and provide that so-called differentiated support, because the agent can understand that, okay, this is what you need at this moment. and not the other thing, and so on. Right. So we basically compute probabilities with the.
If you don't mind,
Yeah, sure. Sorry.
Like the intent analytics.
Right.
Like, it can be inferred explicitly, or it has to be, has to be taken through some web form, something like that, or it has to be inferred.
Right. So that's a good question. When we start a chat, we sometimes ask our customers why they are trying to contact us. So just write a few sentences why you are contacting us. So sometimes we get the intent explicitly. But the task here is to actually predict the intent. So this is even before a chat session starts. A chat or an interaction session starts. So it can be a chat, it can be a voice call, it can be both. But this what I'm talking about is before that.
So can social media imprints or any other?
It can, but there are obviously it can help us in predicting intent. However, the data is very noisy in social media. So when we use it, we have to be very careful. First of all, there are a few legal issues around using social media data, which is not directly coming from a client. Like we cannot go and scrape. Let's say Jet Airways is one of our customers. They are not, but let's say they're customers.
As you told about the speech analytics.
Right.
Intent of the customer. Say, for example, most of the customer contact because
Right.
they are angry.
Right. Exactly.
Angry.
Exactly. So that part we actually leave to the company themselves. That part we won't do that way. So because that is, after all, it's the company. We are basically working on behalf of let's say the airlines to support their customers. So we do a bunch of analytics on the data that we have access to. We don't want to jump the gun and access social media data on our customers' behalf. There are legal complications and procedural complications regarding that.
And how do you build the persona of a visitor?
Right. So that is a sort of a pretty niche research area. So there are personas of basically characteristic. Like not everyone reacts to every situations in the same way or handles a specific task in the same way. Maybe you are a person who takes you look at two products, you make a purchase decision, you are done. There is another person who takes like 10 products, who sit on it for 2 weeks and then makes a purchase decision. There are ways or characteristics from the history that we can identify these personas. See, if you can identify this persona, that can help us predict where in the journey that person is. Does that make sense? I mean, not everybody is the same, right? I mean, there are a lot of behavior that is observed when you look at it at a slightly different level. I personally, when I purchase on the website, I do it like this, but there are other persons who do it a slightly different way. And for a company like Flipkart, who has access to this whole data, they can analyze and they can make those personas.
So, probabilistic estimation models could help here, I think.
It does. So you analyze the data, do let's say an unsupervised clustering, come up with this sort of different clusters, and then you look at the cluster, you make a persona, give that a name, and then you try to predict which persona this person belongs to based on the journey.
So this complete solution which you have highlighted,
right.
If you know all the use cases, then is it used to just the customer is calling and then help the company to firefight over it, or it also is used to act right from the start and just give a call. So let's say the customer is calling, right? Is it even used to respond them that we know that you are facing this issue and we are looking into it?
Right. So that is actually determined on a case by case basis. In some cases, we proactively offer certain like solutions or something. So, for example, let's say you have ordered something and then you are calling. It's most probably you want to know the status. Okay, so sometimes it's reasonably certain why you are calling, and we do provide proactive sort of we call it proactive offers. So these are basically what we can predict, and we are reasonably sure you are calling for that, and we just put it. And then we say, are you here for something else? In some cases, if the ranking of the intents are not that clear, we actually just start with, let us tell. So it gives us both the flexibility of how we can do.
one more thing.
Yeah.
It's like your job ends at the point that you know what the customer wants, or even after beyond that, that how you should react to. Means that you know exactly for what customer has come.
Right.
But even then, after that, you want to give that intelligence to the customer support guy handling it, that how he should react to that.
That is correct. So that is part of obviously our BPO center. They have their own internal training procedures specific to every company, right? Okay, how to handle a specific case. So that is obviously there, but that's not part of the innovation lab department. That's part of.
Sorry, just to add to that, whatever is predicted, right? We do, and this is in tandem with our customers. When customer says that yes, this context should be passed to the agent who is handling the chat or who is handling IVR call, right? So in those cases, we pick up these contexts and pass it to the agent,
Right.
saying that this customer has contacted us for this, or this customer has this specific, might have this specific requirement. So how that helps the agent is directly get to the point. How does that benefit our customer? So if our agent is able to handle the same interaction in a smaller time frame, they need to employ lesser and lesser agents. So it directly impacts their revenue, right? So passing the context actually is done, and we get approval from the client that should we pass this context, this makes sense.
As my doubt was, means like your work ends there by giving intelligence about what the issue is, or it goes beyond, like do some more machine learning on how the customer guy also should react.
So that is not directly embedded over here, but that is taken up in a separate scenario. So we also work on agent training, where we classify the intents. We come up with, okay, for these intents, this is how, so what we learned from our exit survey, one of the point was customer exit survey, right? So we classify, okay, this chat took phase in this manner. This was the comment that we received from the customer, and customer was happy. Then we classify all our chats into intents. Then we go through the transcripts. So there is other intent classification model that we have. We go through the transcripts, we classify them as intents, and then come up with a training plan saying that, okay, if this kind of a scenario comes, these are the agents who are able to do better on these intents. These are the agents who are not able to do better on the intents. This is how an agent who got a positive feedback handling similar kind of a scenario was handling the chat, right? So there are some keywords which you use in your transcript while interacting with a customer. Customer feels that you are empathetic with them, and end of the day, even though if you are not able to solve their problem, right? The way you interact with them, you get a positive feedback from them, right? So more or less than solving the customer issue, it is how empathetic you are towards them, and how best you provide them a solution for that, right?
Completely agree. I mean, at the end of the day, you have to understand that these are all human-to-human interaction, right? These are all facilitating that connection or that support.
So you raised an interesting point that you are also able to identify which agent is handling certain types of issues well. So would the call be also routed in a way that specific, if the intent is known when the call is being made, then that call should go to the agent which is able to resolve, let's say, an order delay issue in a better way? I mean, is that kind of routing also done?
Yes.
Okay.
Yes.
So there are a lot of background sort of routing that goes on before it actually ends up with an agent.
Okay.
So
is there any real world incident that happened which you guys use internally as to showcase how the entire solution worked and gave a good solution where let's say some problem was happened with
Right.
certain customer, and then the intent was identified very well by using the prediction, and then the problem was resolved in a much
Right.
better way because of using of this.
I mean, that's one. The other one is that is the majority of the use case. So that happens most of the time is that we identify the intent, transfer it to the agent, and it gets taken care of.
Have you seen some angry customer also because?
Oh, obviously. Okay, let's continue this the conversation, and then we'll maybe take up a few more questions towards the end. So on the IVR side, again, the problem is the same. How do we identify intent? However, we use a slightly different tactics here. So if you have used IVR system, it's typically like press 1, press 2 and things like that, right? So sometimes what happens is that some of the intents that the customer is there to work on, they are not very easily accessible through the IVR menu. So what we do in those cases is we provide a natural language prompt saying that just tell us why you are here today. And from that prompt, we identify the intent and then basically short circuit the IVR tree so that they can be directly put into that specific area of the IVR. That can either be a self-serve mode so that the IVR system can itself help to resolve the issue for the customer, or it can get transferred to a voice agent at that point. However, the point there where the ML model and the intent prediction comes in is that delivering or predicting the intent from the natural language prompt or the natural language response. One of the emerging use cases that are coming up is in the chatbots domain. So obviously we are very heavily interested in chat and chat agents and things like that, and chatbots fall squarely within this domain. However, the situation is a little bit different compared to you might have some experiences already in using chatbots with a few other companies. There are chatbots that has been deployed. The enterprise situation or the enterprise scenarios are a little bit different than, for example, a conversation with a trivia chatbot, right? So in enterprise scenario, what happens is that you are handling multiple intents simultaneously, sometimes interleaved intents. So in those cases, identifying an intent and identifying when to switch between intents actually becomes very, very important. So there are models that we are looking at, and this is something that, again, this is a very emerging and cutting edge research area, but we'll discuss a little bit towards the end. But here, like for example, you have to not only process the natural language, you also have to detect and detect intent from it. You also have to detect how intent switching is happening when the conversation is taking place. So these are some of the models that we, and there are a bunch of other models both on the intent side and also on the agent side. Like for example, trying to predict what would be the most appropriate response at this point of time, and so on and so forth. But these are some of the models that we would use this type of platform for progressing our business goals. So let's take a quick look at how the technology looks like for this purpose. So at a very high level, what happens is that our solution produces events on both the web platform, web channel, or the IVR channel. So these events are essentially, you can think of like JSON snippets which encode important information. Those events come into the real-time side of the platform, and then once it comes into the real-time side of the platform, then two things happen. Actually, I'll come back to the prediction. So the events eventually flow from the real-time platform to the batch side of the platform, which is essentially a Hadoop system. And we train our models there. Then we deploy the models in our real-time system. That models are used for predicting, and that obviously happens in real time. So the real-time platform is basically responsible for handling the events and then handling the predictions. And also we have the reporting and the BI systems which work on both the real-time system and the batch system. So obviously there are some real-time monitoring and reporting that we do for both internal use and external use. Mostly internal use. The external uses actually comes from the batch side because they are not that quick. So it's more from an operational perspective of, like, for example, model monitoring, system monitoring, those type of stuff. So those data comes from the real-time platform. And then there are batch data platform. The data in the batch data platform is also used to come into the reporting and BI. So we'll take a look into a little bit more detail about the batch side of things, because that's where the most of the important stuff is happening in terms of today's conversation topic. But some of the technologies that we use, just a quick list, and there is no surprises there. We are pretty much at par with most of the technology companies that work in the big data machine learning space, and you know, so most traditional technologies are used quite effectively for our use cases as well. So let's dig a little bit deeper about how things happen within the batch data platform in terms of the model management, model training. Again, these are slightly high level. As you can understand, there are certain considerations that needs to take place in terms of how much I can go about mentioning. However, in general, this is what happens. So the batch data platform obviously receives events from the real-time side, and those events, let's say they come in here, they basically get stored in the Hadoop. No surprises there, right? So we run a bunch of MapReduce jobs on top of the Hadoop data to create a structured data mart. So the structured data mart is important because we have quite a substantial amount of experience in terms of modeling this type of problems again and again for different customers, right? So we know that these are the features that would be important for solving this type of intent problem, right? So we have come up with this type of structured data mart, which essentially gets generated by the nightly MR jobs. On top of that data mart is where we build our regular jobs of training models. So that might happen at, let's say, bi-weekly, monthly, or whatever frequency we want to build models, right? And that obviously depends on that box, but we'll get there. So we do the training, and then then there's this platform. I'm calling it model management platform. So that essentially, so this model management platform is basically responsible for building this model. It is also responsible. So once the model is built and we are happy with the model, we want to deploy it, then it gets into the real-time system, as I was mentioning before.
So these models are trained using Spark ML? Or
These models are trained using Spark, yes.
Spark will?
Yes. Okay. Spark. There is also a R&D pipeline. So we also look at newer models for solving the same use cases. Sometimes we look at new use cases. For example, chatbot models. Those are not something that we have done from, let's say, years, right? This is a very emerging area, right? So we obviously, so those kind of R&D model building cases, we sometimes take data from the structured data mart. We also take data directly from Hadoop to build the data set and the model platform there. Once the data mart is ready, this data mart as well as the Hadoop data stored together is used for the analytics and monitoring for the model itself. So model performance, model metrics, those are very important in terms of managing the model, right? So that then again feeds to a retraining cycle there, so that we can get into a schedule of how we upgrade models and things like that.
Is it possible, for you to describe model management platform a bit more?
So model management platform is essentially responsible for training, monitoring, and retraining. So we'll come to that. It's a little bit there is a little bit more material on that, but it's just a generic name there. So it does a bunch of this type of model-related activities. That's all that happens there. So So if you look at the model building workflow, right? So when we sign a contract with the customer, right? So the first step is for our analyst and our data scientist to go look at the website of the customer, look at the model or the contract that we have signed, like what we need to do, right? So that gives us a reasonably solid set of these are the data that is required for our to solve this problem, right? So a specific intent requires this type of data that we need to collect. So we capture the data that data, and then it comes into. So once the data is captured, it moves into that that big data side of things to start with, right? So then our analyst and data scientist does this typical steps, right? Exploratory data analysis, model building. We do a simulation step just to make sure that the type of target that we want to hit in real time. Like let's say we get 10 million visits per day for a particular customer, and there are a number of agents that are there in the data center in our BPO center to handle the support calls. So at what level should we provide a chat invite so that most people do not get bumped out because there are not many agents available. On the other hand, the number of chats should be enough that the agents are busy. They are not sitting idly. So there is an optimization problem that we try to solve, and try to simulate that so that there is the invites are sent at an optimum level for to do this. And all these things happen in Spark so this the and then once the so a model should not only be able to predict properly, but should also have the parameters in a way so that the other sort of operational targets are achieved.
So this is
Right.
PySpark or?
No, this is Spark ML.
So you don't hit the bottlenecks of unavailability of libraries in Java or Scala.
Unavailability of
Machine learning libraries majorly. I mean, Python and R are much more richer in terms of machine learning libraries as compared to Java.
No, so that's a good question. The type of models that we use for production are slightly different than the type of models we use for R&D. So if you are doing prediction in batch, the type of models that you can use is much larger and much richer compared to the type of models that you can use when you want to use real-time predictions. I was just talking, our SLAs are typically 300 to 400 millisecond. So you cannot possibly try a deep learning model to use in real-time prediction. It just doesn't work. Okay, so there is a smaller subset of models that can be used for this type of real-time prediction jobs, and that is what we. So some of those are there in Spark Spark ML library. Obviously, there are some things that we have written ourselves, some modified models that we have written for our internal purposes, which works better for our use cases.
Like you have two teams, right? Research team and production team.
Right.
What would be the role of each guy?
So the research team typically looks at new problem areas or new models for old problems. Once they are reasonably happy, we deploy it into a couple of customers. Once they are happy that the performance is good.
Only one thing. What is the exact borderline that separates the guys who are into production and the guys who are into
You mean the skill set?
I think like production is one thing. The guy has to write a coding. The other part is like
Right.
research.
Right.
Research guys should be expert in algorithms, right?
Right, that is correct. However, that production coding of the model, that is actually part of the model management platform. So that we'll get to that in a bit. So none of these guys, both the R&D or this thing, they are responsible for deploying the model to production. That is actually taken care of the model management.
Say for example, Airbnb is a very big real estate company. Once the flow is given, ML flow is available, design is available, it is able to completely generate the code.
Right.
But most of the data science companies, we are productionizing so many things. But without the design, is it possible to generate the code whichever?
We actually do that. So our model management platform actually generates the code that gets deployed in production.
So this is the design aspect.
So this model deployment is actually so once this part ends, our model management platform actually generates the code that gets deployed here in this step.
Oh, great. Yeah. So you have automated the.
So we have automated. So that is what that Spark-based framework is. It automates the whole sort of this steps.
So workflow will be designed by the scientist aspect.
So workflow is very standard actually. I mean, there isn't much of a variation in terms of. I mean, you have to do exploratory data analysis when you get a new problem, right? I mean, there are not much variations there. You know, machine learning as a field has matured substantially to get to this level where you kind of know that these are the steps that needs to follow. So why did we need this type of a model management platform to begin with, right? So obviously prediction models is a very key important ingredient for us to achieve this type of targets. However, in our big initial years, what we were seeing is that there are multiple issues that we were facing. So one is that standard transformation. So, you know, we have a large pool of analysts and data scientists who are working on these models. And they were writing their transformations in their own way. That created a problem for deploying them in production. Similarly, for example, the standard libraries. If one is using R, another is using Python, another is using Spark ML. So the libraries are different. They work a little bit differently, you know, based on the implementation, based on the libraries that are used underneath. So that was also creating problem in terms of how we now compare a model which was developed in R versus developed in Python, and so on, right? So how we can compare models or how to select one runtime. So we cannot support like 10 different runtimes to offer models in production, right? So that was creating problem as well. And then there is a problem of skill as well. Not everybody is up and running at the same level as, let's say, a person who is working for 6-7 years on this type of models. So so these are some of the main issues why we sort of standardized into this model management platform.
So on the library side, you standardize on Spark ML.
On the library side, we standardize on Spark.
But isn't it a very difficult problem, like for training data scientists to work with Spark ML, specifically
it's
Scala?
Not. We'll get to why.
Okay.
So we have basically abstracted out all those things.
So when you are saying that comparing the models, you are talking about the same
algorithm, but processed through different software libraries. Yes. So our early iteration on this model management platform was built on top of a software called Vertica. You may have heard of. It's used to be from HP. Now that they have spun up that company, it's called Micro Focus now. It's a columnar database with very strong analytical query capabilities. So what we used to do is we loaded the output of MR, that MapReduce job that used to happen on the batch data platform. We used to load that data into Vertica. It's a multi-node cluster, Vertica cluster, and then which basically acted as our data mart, right? So and then the model workflow. So it's the same picture, just filled in the values there in some sense. So we used to write Vertica UDFs, and these are written in. This can be written in R or C++, and so those are the ones which were responsible for training the models, right? So once the UDFs they used to run on Vertica, so this is an in-database sort of operation. So let's just look at the. So the EDN computations happened in database. So there were no substantial data movement that was happening, except obviously the initial movement of loading the MapReduce data from HDFS to Vertica. And it supports SQL and R, thus resulting in reasonably easy onboarding for analysts and data scientists. They are that type of skill set that we typically hire, and they obviously had that skill set. So that was reasonably easy to onboard.
So this is all about EDA, right? You begin with EDA?
Obviously, right? When we look at a platform, we have to obviously do a bunch of EDAs. We have to do a bunch of transformations and things like that to get to a stage where we...
Is R tool more than enough for EDA?
R is very good for EDA, yes. R is very good for EDA. However, what we noticed is that, so one of the reasons I said, right? So we cannot, R is not a very good, it's a good tool for prototyping data science models. It's not a very good tool when you want to deploy a prediction model for real-time prediction where you need like 200, 300 millisecond response rate. It's just not possible, right? So then we were seeing issues like, for example, the data scientist would write a code in R that gets translated into some other code in other language, and there were bugs happening there. So that obviously was slowing us down in terms of deployment and things like that. So that didn't work well. So the cons were obviously, so couple of things, like some speed of computation, etc. These are technical. Like small community of developers when you compare to it's reasonably large, but still it's much smaller compared to, let's say, Spark sort of thing. The model deployment, these issues, these technical issues were there, but this type of issues were also there, like cumbersome model deployment workflow, right? Because there are multiple sort of bugs that are arising because of this how we were taking it, like data scientists doing a different language, this guy's getting with models getting in production in a different language and so on. Right, and obviously there is a license requirement. Vertica is not a free product; it's a licensed product. So that versus we had an existing Spark cluster already because we were running we ran Hortonworks. So obviously Spark was already available. So that was one of the main reasons why we moved towards Spark. So obviously Spark is a strongly it's a distributed computation engine with a huge community. Also, it is a general purpose sort of tool. So, ML is just one of the things that needs to be done, right? That's not the only thing. There are a bunch of things that has to happen to the data before we can reach to that ML step. Obviously, I mean, you looked at Shashank's presentation, right? So the amount of things that need to happen, including data munging, data cleaning, most of the reports say it is around 80 to 90% of the work before you actually get to the model stage, right? So the model is obviously has to be good and so on and so forth. However, there are a lot of different things that happen before that, and SparkML actually can help you in speeding up those things in a standardized way, right? So we wanted to expand the model building to more use cases. Like for example, I was talking about chatbots and things like that. So those type of models, like for example, NL models are not that strong in R. Python is a good one. Spark is also another one which has other libraries which sits on top of Spark and provides that type of functionality. Spark models can also, we could directly deploy on our production JVM stack. So we run a JVM stack for our production machine learning platform. So we already had a Spark cluster which was getting used for ad hoc queries. So that was sort of an easy decision at that point. And there is a couple of other sort of more technical ML specific reasons. For example, this is what Shashank was also touching a little bit. Of how we can sort of skip some of the feature engineering steps by using hashing tricks and things like that. That was also one of the reasons why we wanted to move towards this type of.
Elaborate on this point?
Yes.
Last one only.
Yes, we'll come to that. So in this case, how it looks like is essentially, so the structured data mart is still HDFS vertical. However, the data in this case is in the so when we are looking at the Spark cluster for the model management, so we obviously have a cluster for managing the models, managing this whole workflow, right, of EDA to model building to simulation to generate the code that is ready to be deployed. And so these steps, this happens in the Spark cluster, and so that can read data from both vertical and HDFS based on the use case to use case basis. And once the training is done, we can deploy it in the usual sort of the usual pipeline that we use, right? And
sorry, what is the usual pipeline?
For the
where are you deploying it?
So as I was mentioning, we deploy our deployment stack is on it's a JVM stack, basically a JT server which runs the model. Runs the prediction models. So prediction models are typically just let's say for most of like LR and so on, SVM, they're just dot products, right? So you basically encode that and.
But they are available to the other systems more or less as a microservices.
They are available as microservices. Yes. Okay. Yes. So when we deploy our solutions to our website, to the customer's website, let's say take one of our customers. When we deploy our solutions, that solution send a post call to our REST service. And that REST service in turn runs the prediction and returns the prediction. Then the client-side library takes up the prediction, interprets it, and shows a chat invite or does a bunch of other interventions. So that intervention depends from case-to-case basis. And that can be done from both web or even an IVR. All these platforms are now capable of REST calls, right? So we do it as a REST service, sort of a microservice architecture, and it just.
But then every single model will be a different microservice.
So it's not like that. So we have a separate sort of architecture where we store the metadata of the model separately, and there is just one platform that gets hit by the that basically serves the REST layer, okay. And that internally talks to the metadata service. Gets the specific model that is used for that specific, let's say, client, customer, and a bunch of other parameters. It picks up that specific model, computes the prediction, and goes back. So there is an abstraction on top of. Obviously, there are specific models for specific use cases, but not every model is deployed as a specific microservice.
Okay.
In the model management platform based on Vertica, in the model management platform you have mentioned Vertica plus Uzi.
Right.
So you don't need any.
Here, the Spark actually has its own engine for scheduling and all those things, right? Basically, Yarn. I mean,
when will that be triggered? You don't need anything for that.
Sorry,
So Spark takes care of where should I be running the jobs. And
right.
But when a particular model training should be triggered, how do you?
So that is actually coming from the analytics and monitoring side. Like for example, when we see, the initial training of FM model is a user action, right? Okay, now I'm ready to train a model. So I click a button, the process starts.
Okay.
Once the model is deployed, then it goes in through an analytics and monitoring sort of phase,
Okay.
where that determines that, okay, this is a point where the model has deteriorated enough that we need a retraining. And so that again starts that cycle. Sorry?
Like periodic modeling.
Right.
It's automatically.
We are in the process of automating it, but the idea is to automate it. Yes. Right now it's more of a manual, this thing. These are automated, but I think we are. So what we did is, so in order to satisfy this type of thing, so what we did is, this framework is a wrapper around Spark libraries. We developed this in-house. We have specialized modules to manage, for example, provision for config file reading, provision for reading data from HDFS and Vertica, provision for output models to be available as both bytecodes and as some other legacy formats. So these are after the training, right? The models are available, how the models are available for deployment. Provision for supporting custom model training workflows, including post-processing. So, for example, some of the use cases might be different. Like maybe R&D wants to use certain models or tweak certain models to fit to specific use cases. So how can that be done, and so on. And there we also have done some APIs for accessing the individual functionality of this platform. It needed around 8 to 9 man months to, okay, I say complete the project. It's still this project's never complete, but but at a stage where this can be used for.
So one question is like, what are the legacy formats you support?
Right. So we'll come to that. So there is a little bit of.
So also, like when you said provision, it was like some configuration driven kind of thing? Or
Right. So yeah, okay. I wanted to mention a little bit on that. So this platform actually is a config file driven approach. So basically, whatever parameters that we want to use for our model training purposes, they are encoded in a config file, and the Spark job essentially reads that config file, determines the stages in the pipeline that needs to happen. And it's done very similarly to what Shashank has said. It's a pretty standard procedure as of now. But as Shashank was mentioning, some of the steps that can also be done outside of pipeline, we have moved into the pipeline just because it's a lazy evaluation, like what he was mentioning, and that happens on demand. So we obviously have those caching and all those things to speed up at certain respects. So very similar to. So look at his presentation again. It's pretty much how we have done it. Those are very good best practices and things like that.
Apart from config, there should be some specific business specific thing which will be going in.
Right. So we'll come to that. I think it's not here. That are the okay. We'll come to that. So I was talking about the hashing trick, right? So what happened? What we saw before we moved to, and that is not necessarily regarding to Spark or something. But there is this, and even Shashank mentioned this, you saw that string indexer and things like that, right? So what we have seen is previously our data scientists and our analysts, they were setting up columns which were basically created out of a large text field. So those are basically custom features. So this is what we traditionally know as feature engineering, right? You create features out of what is available to you, like the data that is available to you, and then you throw it to the model. However, what happens is that in the newer versions of Spark, there is this feature called hashing TF. It basically takes into account and it basically projects the input string itself in a larger dimensional space. Once it projects to a larger dimensional space, then you are relieved from actually hand encoding those features. So the minute differences in the features that you were trying to capture through individual customized features, that essentially gets taken care of by that large vector that you have projected from that text input.
Is it like SVD method?
Is it like
It's not SVD.
Is it like parallel to PCA for string?
You can think about it. No, it's not even PCA, because PCA basically compresses the number of columns that you are using for
But that
feature.
again
This is actually expansion.
dimension, right?
Is it equivalent to TFID?
It is like TF-IDF. So it's essentially it's called hashing TF for that matter. It's a term frequency. So you hash it out to a larger dimensional space and then find the term frequency. It's a standard method available in Spark. I think from 1.6 or 2, maybe 2 from 2 onwards. So what it does is, let's say this is the array of features. Like this might be an array of strings, right? So you want to create. So rather than creating, let's say, a regex-based application of feature extraction from the string, you will do it through you will basically pass it through multiple operations, and this library is there in Spark. We didn't do anything on that side, and this then scales it out to a large large vector, maybe it's 10,000, 12,000, 15,000 size vector, so that very minute differences in strings can get captured by that large dimensional vector space, and then you compute the TF, and that becomes your feature vector instead of the manually created feature. So that actually is very easy to deal with categorical variables in this way. So we used to do a bunch of custom features before that we have stopped doing since we have come across this, and that we have seen in our experiments that this has helped us in getting almost the same accuracy, if not in some cases better. It is especially better when the effect is more prominent when we were doing more of those, right? There was, let's say, URLs that we get as part of the web journey, and we used to create multiple like what is the product, what is this, what is that, those type of custom features we used to extract out and create as features. And now we just do this, and it basically provides us pretty much the same sort of accuracy and prediction in terms of achieving our goal there, right? So that is actually a standard feature in Spark. So I would recommend you guys to take a look at, especially the cases where you are using custom feature engineering from text inputs. Obviously, the model training here is much faster compared to the legacy method. We are able to use distributed computation among nodes, and then, for example, like we recently did some benchmark. So we see a speed of around 2x to 5x improvement in terms of row when we, and these are one of the smaller data sets. So our data set is typically much larger than this, but some of the smaller data set, for example, a million sort of row data set, that itself we see 2x to 5x improvement, and so that obviously helps in terms of so because there is a finite pool of people who develop these models for the clients that we serve, right? There are not, I mean, it's not like every person is associated with one client, and so we just keep hiring. It's not like that. So there is a finite pool of people who works in all these accounts to customize these models and things like that. And then there are R&D and things like that. So naturally that helps. The question that came up about that business logic, how you deploy. So what we do there is we actually use a mix of JavaScript code and Java byte serialized code to create a DAG of model, which actually gets deployed in production. So let's say there are business rules that we have to follow. For example, we can only show 3 chats in a session. We cannot show 20 chat invites. It's just not possible because it deteriorates the customer experience and things like that. So there are these business rules that we have to follow. So those rules, it doesn't make sense to encode them in models. First of all, they are difficult, and it just doesn't make sense because those are business rules. They have nothing to do with machine learning, intent prediction, this, that, etc. So what we do is we encode those into JavaScript, and then we have other parts which are basically core machine learning models like linear regression, naive-Bayes, SVM. Those type of models, we keep it as a Java byte serialized format, basically the Spark format. It can be Parquet. There are other formats also, and then we actually form a DAG of these models, which gets evaluated in prediction. So that is what essentially is what we will. So hopefully that answers the question of how we take care of the business case. The complex models are obviously still kept in the Spark format so that it can be run faster. Otherwise, the JVM just takes up the JavaScript string and then executes it in real time. Right? The faster cycle of faster cycle of model training, testing, and deployment, as obviously that helps. So this is pretty much the last slide. So some of the things that we are currently working on is one of the things that we are very important for us. On the chatbot side, we are exploring the deep learning paradigm and the deep learning models, because these models are the typical NLP models are not sophisticated or strong enough to support this type of continuous natural language input output. So there are models like sec-to-sec models, sequence-to-sequence models you may have heard of. There are type of models which are much more powerful to handle with this type of use cases, right? So there are libraries available on top of Spark. For example, we are looking at MXNet at the moment, but there are other alternative libraries that we will probably look at as well for doing this type of conversation, modeling this type of conversations. We have also worked on some innovations in terms of sampling, solving optimization problems, training SVM models in Spark Library. Hopefully, we'll be able to share some of this with the Spark community, like as Shashank has done. So we are also hoping to do something similar, some pull requests and stuff like that. For example, in terms of sampling, right? So Shashank was talking about random sampling. There is another very powerful method called stratified sampling, which is very important when you are dealing with multi-class classification. So in most cases, if you have noticed, so you are determining intent. So one way, so there are typically like let's say 10, 12, 40 intents that we have to predict, right? So one way is you do binary classification for each intent. This intent, not this intent. This intent, not this intent. But that's a pretty cumbersome process, right? So the other way is to do a multi-class classification, multi-intent problems. So for example, Spark has support for multi-intent logistic regression, multi-class logistic regression model. That is actually a very powerful model. However, that needs that you have to sample the data. So now think about, let's say you have a multi-intent data. You have data, a large data set containing 40 intents. However, some intents will have more data, some intents will have less data. Now you have to have some intent, some data for a specific intent in the training. Otherwise, you cannot predict that in test, right? So you have to do a stratified sampling so that at least some of that intent shows up in the training data. And maybe that is not sufficient. So sometimes what we do is we use a cutoff to sort of prevent and just do it as other intent for that moment till we have enough data so that we come back to that stage at a later sort of retraining phase, and then we analyze that as a proper intent. So there are this type of innovations that had to happen so that we can sort of support all the intents that we want to predict. So I think that's pretty much all I had. Yeah.
Some intent has been predicted.
Right.
So it's very tricky to evaluate or validate. Like, what's the measure you are taking?
To check whether the intent is yeah. So that depends on. So there are a couple of ways. For example, think about a speech or even a chatbot or a chat scenario, right? We predict intent that this guy is going to talk about this thing. Okay. So then the customer support agent or the IVR system prompts, are you planning to ask about this? If the customer says no, that's the validation. That means we did something wrong. Obviously. So that gets fed into the training cycle. So we have some data collected, we train on it, deploy it, collect more data, and then see where we were missing, and then again feed it back to the training process. It's an iterative process, right, as usual.
So you mentioned 2x to 5x improvement with Spark. So what was the framework before that?
So the framework was Vertica before that. So Vertica, unfortunately, the UDFs that we wrote for this model training and things like that, the UDFs run single-threaded. They cannot run multi-thread in a cluster sort of situations. They only can run on one node in the Vertica cluster. So that gave us an immediate jump in terms of, because now in Spark you can basically distribute it across your cluster, right? And obviously we have a pretty large cluster for doing this type of for holding that much of data, right? So we have a pretty large compute cluster to do that.
So Vertica also was using some sort of cluster or no cluster?
No. We had a Vertica cluster. However, that was if it is a native database operation, it can distribute it across cluster. However, these models are UDFs, like R UDFs on top of Vertica. So Vertica has an execution engine which can run R UDFs, C++ UDFs. Unfortunately, those UDFs, at least up to this point, they are single-threaded. They cannot get distributed. Does that make sense? Yeah. Any other questions? Yeah.
So as a product, the offering that you offer, is it hosted on cloud or do you?
This is a cloud-hosted product. Yeah. So these things are obviously background stuff, right? The product. This is not the product. This is just enables us to do our business, right? And that product that we sell is essentially the agent platform that takes the chat, voice calls, and things like that. We basically sell agents. We sell platform. We sell agent and platform. So there are multiple combinations of.
So from
as
product
a
point
business.
of view, if you want to look at it, you can divide it into two categories in terms of channel. One is web, the other one is phone. Within web, it is a chatbot or chat agent. On voice side, it's phone IVR. So in phone IVR, then there comes agents as well, right? So that is how we classify it. Now, the part where we come in is we have a product and a lot of companies have these products, right? How do we edge over them? So if a company is providing IVR and we are providing IVR, what is it that gives us a step ahead of them? It is this, right? Because if we input these kind of feeds into IVR, just let's take an example. How much does it cost for each time a customer gets connected to an agent, right? Now, if we are able to predict and we are able to increase the self-serve rate on IVR channel itself and not connect to your agent, that is a cost saving every contact that we reduce, right? That is what will give us an edge over others. Does that answer your question?
Yeah.
So we have that predictive sales, predictive service, right, at the top in the product listing. This is basically what he's talking about, the predictive sales. That is what we offer. So there can be other solutions which is just simple sales. So we don't do the prediction. Maybe some customers are not interested in the predictive side of things. They just want to support customers.
Now,
We also sell.
like Samik talked about vivid speech, right? It's just your IVR. But we are enabling you to collect additional information over your IVR. Now just imagine you are interacting with a customer and you are an airlines company, you are communicating to a customer and you are telling them that these are the flights available, which one would you like to select? Now the customer will ask you to repeat that because he will not capture all the info. You just push a slider to his phone and ask him to just click on that, read through it and click on that. Agent time gets saved. Customer, you have a better communication channel with the customer, and hence your interaction is more interactive and it shortens the time frame for which that interaction goes on for, right? So that is what vivid speech helps us achieve.
How do you push that notification you were saying? You'll need to have an app installed on the phone.
Right. So that part, obviously, there is a technology enablement for that. We work with the client to deploy that type of solution. Yes.
And in the times of strict privacy laws for the customer like GDPR, how do you handle the customer privacy and the
Right. So obviously, we would majority of our customers are international customers. In fact, we have customers from multiple continents, right? And each continent has got separate stringent rules for privacy. So we have to abide by all these rules. So for example, we hash all the what is known as PII, personally identifiable information. So we obviously hide or secure all those things so that nobody can take any advantage. So the data that you see, that we see for model building purposes, doesn't contain any of, for example, credit card, social security number, this, that. None of those are applicable to us.
So how big is the Spark cluster?
So the Spark cluster, maybe
Sanjeev is the right person to respond.
Yeah, exactly.
It's using the same HDFS.
Right. So it spans the whole this thing, right? So I don't know how many compute nodes we have. Right now.
50 nodes. This is 1 petabyte. 60, I guess. So it keeps adding.
Yeah, that's why I'm not the right person to do.